Welcome back to my channel. Let's start with today's astounding video, shall we? Fire, at its core, is a rapid chemical reaction known as combustion. When a fuel interacts with oxygen and is heated to a specific ignition point, it produces heat, light, and various gases, often in the form of flames. Flames are a mix of hot gases, including carbon dioxide, water vapor, oxygen, and nitrogen, and they emit light due to the thermal excitation of particles within the flame. Fire on Earth is dependent on three factors: fuel, oxygen, and heat, often represented by the fire triangle. This reliance on oxygen makes fire rare beyond Earth, as most celestial bodies lack a significant atmosphere with oxygen. Fire, as we know it, is unlikely to exist on other planets or celestial bodies in the solar system. For instance, Mars has a thin atmosphere with only about 0.13% oxygen, far too little to sustain combustion. Jupiter, Saturn, and other gas giants lack solid fuel and oxygen-rich atmospheres, making fire improbable. The Moon, devoid of any atmosphere, cannot sustain fire as there's no oxygen for combustion. On the Sun, fire doesn't occur because its energy comes from nuclear fusion, not combustion. While fire requires oxygen and fuel, the Sun's reactions involve hydrogen atoms fusing under extreme pressure and temperature, releasing enormous energy. The three states of matter are solid, liquid, and gas. Plasma, the fourth state of matter, is a high-energy state where atoms lose their electrons, creating a soup of charged particles, free electrons, and ions. Unlike solids, liquids, and gases, plasma conducts electricity and is highly responsive to magnetic and electric fields. Plasma forms when gas is heated to extremely high temperatures or exposed to intense electromagnetic fields, causing electrons to break free from their atomic nuclei. Plasma is found in lightning, neon signs, and flames, though it is distinct from the chemical reaction of fire. Plasma is far more widespread than fire in the cosmos. The Sun is a giant ball of plasma. Its surface, known as the photosphere, and outer layers like the corona consist of superheated plasma. These layers emit light and heat through nuclear fusion in the Sun's core. Jupiter's magnetosphere contains plasma created by volcanic eruptions on its moon, Io. Io ejects sulfur and oxygen ions that become ionized, forming plasma trapped by Jupiter's powerful magnetic field. Solar winds, which are streams of charged plasma particles emitted by the Sun, flow through the solar system, impacting planetary atmospheres and creating auroras on Earth and other planets. The Moon, while not generating plasma, is occasionally exposed to plasma from solar winds, particularly during periods when Earth's magnetosphere directs plasma toward it. Fire is a fleeting chemical phenomenon confined to environments with oxygen and fuel. Plasma, on the other hand, is a universal state of matter found in stars, interstellar space, and even in everyday technologies on Earth. While fire may be an Earth-centric phenomenon, plasma is the fabric of the stars, the engine of solar winds, and the key to understanding much of the universe's energy. Together, they remind us of the incredible diversity of energy and matter in our cosmos. The heat we feel from sunlight is not because plasma travels from the Sun to the planets. Instead, it's due to radiation, the transfer of energy through electromagnetic waves. Here's how heat travels from the Sun. The Sun emits energy in the form of electromagnetic waves, which includes visible light, infrared radiation or heat, and ultraviolet rays. This energy travels through the vacuum of space at the speed of light. When sunlight reaches the Earth, the infrared portion of the spectrum is absorbed by our skin and surroundings, causing molecules to vibrate more vigorously. This molecular vibration is what we perceive as heat. Earth's atmosphere absorbs and scatters some of the Sun's radiation. For example, ultraviolet rays are mostly absorbed by the ozone layer. Infrared rays partially penetrate and warm the Earth's surface, creating the sensation of heat. Does plasma travel from the Sun to planets? Yes, but not in the form of heat. Plasma travels from the Sun to the planets in the form of solar wind, but this plasma does not directly heat us. Here's how it works. The Sun's corona, which is made of superheated plasma, ejects streams of charged particles, electrons and protons, into space. This flow is called the solar wind. Solar wind spreads throughout the solar system, interacting with each planetary atmosphere and magnetic field. Earth's magnetic field deflects most of the solar wind. However, when particles from the solar wind interact with the upper atmosphere, they create phenomena like auroras. Other planets without strong magnetic fields like Mars experience direct interaction with solar wind, which can strip away parts of their atmosphere over time. The heat we feel from the sun comes from electromagnetic radiation, not the plasma in the solar wind. Plasma from the solar wind is sparse and mostly deflected by Earth's magnetic field. Even when it reaches Earth's vicinity, its density and energy are too low to cause direct heating. Instead, solar radiation that is light, carries immense energy, and travels efficiently across the vast vacuum of space. Solar wind is more significant in space weather phenomena than in direct heating. The warmth of sunlight is due to radiation. Plasma from the sun travels across the solar system, shaping magnetic fields and atmospheres, but not directly contributing to the heat we feel on Earth. So now we know about fire, plasma, solar wind, and solar radiation. If you learned something new today, do smash the like and subscribe buttons. With much appreciation and gratitude until the next time. Take care of yourself.